This is exercise 1.1 question number 4. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m, right? Here you try to understand the format of the square of any positive integer is supposed to be this one. Now here suppose my integer is a and this is divisor, this is the remainder, this is the quotient. So according to the Euclid's division lemma, we write down here a which is equal to bq plus r, right? But at this place our b is what? B is 3. Format, look at the format here. 3m or 3m plus 1. So 3 is always what? It is the divisor. So at this place what I will write down? 3. So the format of our integer is 3q plus r. Okay, this is the format. Now before starting showing you how to get this format, first try to understand. Suppose I take 2 and I make the square of it. So it is 4. 4 I can write down 3 plus 1. 3 means what? 3 into 1 plus 1. This 1 is some integer m. So format will be what? 3m plus 1 is the format. Correct? Here I'll write down 1. Now take the another one. Suppose 3 square. 3 square is what? 9. 9 means what? 3 into 3. This 3 is another integer. So the format is 3m. Right? Now take the other one here so that we'll get the confirmation. 4 square which is equal to 16. 16 means what? 15 plus 1. 15 means what? 3 into 5 plus 1. Look at this, 5 is some another integer. So the format will become what? 3m plus 1. Now make the square of any number, then its format will become 3m plus 1 or 3m. And we are going to show this only. Okay, let us see the answer now. Here, let a be any positive integer and b is equal to 3. So according to Euclid's division algorithm, we will write down our integer as a which is equal to 3q plus r, where r is greater than or equal to 0 but less than 3. Try to understand. Suppose here I said our a is there, here 3 is there, here q is there, and here remainder. Our remainder may be 0 or may be greater than 0, but it should be less than 3. Okay, so therefore the possible remainders are what? Either it is 0, maybe 1, maybe 2. Correct? Our r. See, r 0 possible, 1 is also possible, 2 is also possible, but 3 is not possible because our r is smaller than 3. Correct? So according to this one, I can write down my integer here. See, a which is equal to 3q plus 0. 0 doesn't have any value, so 3q. So this is first format. A which is equal to 3q plus 1. I am just replacing this r with 0, 1 and here 2. Correct? So we got these 3 forms of integer. Now what I will do? I will make the square. So here a square which is equal to 3q square. 3q square means what? 9q square. 9 I can write down 3 in the bracket 3q square. This, the bracket thing, is some integer which we are calling it as m. Right? So m which is equal to 3q square. So a square which is equal to 3m. This format we got. Now come to the another integer. A which is equal to 3q plus 1. So we'll make the square of this one. 3q plus 1 the bracket square after making the square of both the sides. You know the identity a plus b the bracket square, right? If you don't know that identity, just see here. A plus b bracket square which is equal to a square plus 2ab plus b square. So according to this identity, what we will do? We will just make the square of the bracket. Okay. So see here. Here 3q square is 9q square plus 2 times 3q into 1 is 6q and 1 square is 1 here. Okay. From the first two terms, what we are taking common? 3. So 3 in the bracket 3q square plus 2q plus 1. So this, whatever the things are there in the bracket, that is nothing but the another integer which we are calling it as m. Now look at the format here. A square which is equal to 3m plus 1. Correct? Now come to the third one. Once again, we are having the integer a which is equal to 3q plus 2. Make the square of both the sides here. Now according to the same identity, we are writing it 9q square plus 12q plus 4. This 4 I can write down 3 plus 1. Right? I can do that one. So here from the first 3 terms, we have taken 3 common. Now whatever the things are left in the bracket, that is some another integer. We are calling it as m. And this plus 1 as it is. Now look at the final this one forms. Here 3m, here 3m plus 1, here also 3m plus 1. That means square of any positive integer will be of this format. Right? So finally we have written here. Therefore, the square of any positive integer is either of the form 3m or 3m plus 1. Correct? I hope all of you understood this sum.